Welcome back guys. Today in this video tutorial I'm going to start up a new sensor that is SI7020-A20. Now in the previous videos I have done a lot of digital sensors for humidity and temperature. So let's add a new one to this list. To explore the sensor and its features and let's have a look over the website, that is controleverything.com, and here search for the above sensor which we are going to explore today, and let's see what we got for that. As you see, it's a humidity and temperature sensor, plus minus 4% RH, plus minus 0.4 degrees Celsius is the accuracy, is the precision of this sensor. You can see the range for humidity and temperature and excellent long-term stability. Now these are some of its features which we're gonna look above, and you can purchase this sensor from this very site from here. Well, in this video I will be interfacing the humidity and temperature sensor SI7020-A20 with the BeagleBone Black, and the software platform I'm using will be C language. And to get the code, go to Resource tab, and here comes the C code sample. Now you can download the C code sample as a zip file from here, and also you can have the code from github.com, and the repository there is Control Everything Community. Now let's have a look over the hardware connections we need for this setup. Coming to the hardware section, first of all, the requirement which you are able to see on my screen is this, the BeagleBone Black, and it's available. Now the second thing we require is this, an I2C Shield. It's available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, gently place this I2C Shield over the BeagleBone Black and make a connection just like that. Now we need our sensor, that is the humidity and temperature sensor SI7020-A20, and this is a connecting cable. Make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and for the same reason to the I2C shield. Now we need to provide the power backup for the BeagleBone Black, and there are two things we require for that. First of all, this is a mini USB cable, as you can see, and gently insert it over this jack right here. And next we need an adapter of 5 volt supply, and gently push over this on the power jack. The last part is to provide the internet connection, and for that we require this. As you can see, there are two ways. First of all, an Ethernet cable or a LAN cable can be required, and gently insert it over there, Ethernet jack. And second thing, we can also use a wireless nano USB adapter. So we are done with the connections part. Now what we require is to have a look over the code, and let's interface. Now for the interfacing part, we need to find out the code, and for that we have to log into github.com, and here we have to search for the repository, there is Control Everything Community. After that we have to search for the sensor, as you can see on my screen, it is SI7020-A20, and this is the C code. Let's have a look over the instructions first. As you can see, we first have to set up and connect the BeagleBone Black, and all the relevant information for the setup procedure is provided on the link, that is beagleboard.org. And after that we have to download or git pull the code in the BeagleBone Black, and this is the command to compile, and this is to run the code, the C code. After that, get back to the C code. As you can see, notice that it's a .c extension file. In the code you will observe that we have included some of the header files, and in the void main function we have created an I2C bus, and this is the condition to check whether bus is there or not. And after that we have to check for the I2C device, and the address of the sensor is 0x40. Now coming to the writing section part, we are going to send a command for humidity measurement, and it is no hold master mode, and it is 0xF5, and here it is the writing command, as you can see. Then we have a sleep of 1 second. In the reading section part, we are going to read 2 bytes of humidity data, and as you can see, this is the reading command here, and then the conversion of the data takes place here, which is according to the formulas provided in the data sheet of SI7020-A20. Then we want to display the output data onto the screen, which is the relative humidity in percentage RH. Similarly, we are following the procedure, and we are going to send the temperature measurement command, no hold master mode, that is 0xF3, and here comes the writing command of that. Then we have a delay or sleep of 1 second. After that we have the reading section, in which we are going to read 2 bytes of temperature data here, and then we have the conversion of the temperature data according to the data sheet, and at last we have the output which is the temperature in Celsius and Fahrenheit scales. So we are done with the code. Now we want to display the working on the screen, and let's have it. Now for the working environment part, the first step is to copy this entire code as you can see on my screen, and after that we have to open up the BeagleBone terminal as you can see, and here we have to create a new file as you are able to see on my screen, and here we have to paste the entire code, and after that we have to save it, and this is the command as you can see on my screen. This is to compile the code which you have already seen in the instructions part, and let's see what we got here. The code has been compiled successfully, and this is to run the code and to build it, and let's see what we have here. And you can see we have the relative humidity in percentage RH along with the temperature in Celsius and Fahrenheit, and when I again run the command, the values are displayed onto the screen, and you can see the pattern here. The values are almost constant because there is no change in humidity and temperature, but when I press my finger over the sensor and run the command, you can see there is a change in relative humidity and in temperature, and when I again do that and run the command, you can see the changes again for the relative humidity which is in percentage RH along with the temperature which is in Celsius and Fahrenheit scales. So this is how the sensor works. Now let's have a look over the applications and the benefits of this sensor. The SI7020-I2C Humidity and Temperature Sensor is a monolithic CMOS IC integrating humidity and temperature sensor elements and analog to digital converter, signal processing, calibration data, and an I2C interface. The patented use of industry standard low K polymeric dielectrics for sensing humidity enables the construction of low power monolithic CMOS sensor ICs with low drift and hysteresis and excellent long-term stability. These applications are like HVAC, thermostats, respiratory therapy, microenvironments, automotive, climate control and defogging, asset and good tracking, indoor weather stations, and a lot more. So these are the features which make a lot of applications like this. So now you can purchase the sensor from the website controleverything.com as you can see on my screen, and also you can get the code from the resource tab, and after that you can download it. You can get the code from GitHub repository that is called Control Everything Community. So in the end, I just thought that I would like to make it clear that in case you guys are feeling like you are left without fully understanding any part of this code or this video, you can have your queries on controleverything.com, and you can post your comments on the community page. Now, for blogs, articles which are relevant to this video, you can contact us on instructables.com. And to subscribe more video tutorials like this, you can subscribe our YouTube channel. In the end, I hope you enjoyed this video. You and yourself have a good one. Thanks a lot for watching.